Okay, so in today's lesson, we're going to talk about finding equations of lines, and you can do that pretty easily with two pieces of information. First one we're going to talk about here is called point-slope form, and that's the equation of a line in point-slope, and as its name would imply, you need the point, any single point on the line, and the slope. Now, we should be familiar with slope being represented by the variable m, and then the point in this form is represented by x sub 1, y sub 1. So you would simply just plug these in. The slope would go there, the x-coordinate of the point, and the y-coordinate of the point. Notice one thing here is that these are subtraction. So if you had, say, y plus 3 as part of your equation, you need to understand that the formula is y minus y sub 1. So this is actually a negative y value for the point. So just a quick thing to note there. Our most common form is going to be slope-intercept, which you should have done a lot of in Algebra 1. So we'll look at that example here. And we're asked to write the equation of a line in slope-intercept form that has a slope of -1/2 and passes through this point. Well, I know that slope-intercept is y equals mx plus b. So if I can identify the m and the b, then I've written my equation in slope-intercept. And I know that the slope is represented by the variable m, and I see that here as -1/2. So I know m equals -1/2. What I don't have is b. And then there's also an x and a y in here, and since I'm trying to find b, I do have a point. So I have an x of -2 and a y of 3. So if I begin to substitute these into my equation, and then I have my unknown b, I can begin to solve. So I have 3 equals, and I have -1/2 times -2. That's a positive, and it's going to be 1. And then I still have the plus b. So then I subtract 1 from both sides, and I see b equals 2. Again, now that I have my m and b, I can write the equation of the line in slope-intercept. So it's y equals -1/2x plus 2. You can certainly always double check yourself by plugging in the point. So I can say 3 equals -1/2 times -2 plus 2. Again, this would be a +1 plus 2 is 3, so that checks. So there is my equation of the line in slope-intercept form. And if we look at the one right below, we can do the same thing. I'll write my equation. I identify what I know. It says I have a slope of -1/3. And I have a point. So again, every coordinate has the values for an x and a y. So I have an x value of 6, y value of 4, and so what I'm missing here is the b. So I'll sub these into the equation. Four equals -1/3 times 6 plus 4. And then we solve for the unknown, plus b. So then we're going to solve for the unknown quantity. So 4 equals -1/3 times a +6 is a negative. 1/3 of 6 is 2. Add it to both sides. And b equals 6. Now again, I have my m and b, so I can write the equation of my line in slope-intercept. And it asks us to verify the answer graphically, so we'll pull up the graphing calculator here and we'll double check. I go to y equals, I'm going to plug this in. I'm going to go ahead and put it as a stacked fraction, make it look exactly like that. And I do that by just hitting the alpha y equals key. So -1/3 times x plus 6. There's my graph. And I'm going to verify that the 0.64 is on it. I can easily do that by going to my table. And I see 6,4 right there. And we'll look at another one. This one asks us to find the equation of a horizontal line. So I'm going to draw a quick x and y axis here. There's my y, x, and it goes through the point negative 3, 7. So that's going to be negative 1, 2, 3, and somewhere up here, 7. We'll call this negative 3, 7. And it's a horizontal line through that point. So it looks something like that. This is a pretty easy equation to write. You should see it's perfectly flat. So your slope, your m here, equals 0. And because it's at negative 3, 7, I know it's going to intercept right here at 7. So if I plug this into my slope-intercept formula, and I sub those values in, I can plug in the coordinate if I need to, but really I have m and b, so I don't need to do any of that. All right, y equals 0 times x plus 7, and 0 times x cancels out. So you end up with a simple equation of just y equals 7. So horizontal lines are y equals. In a second here, you'll see how the equation of vertical lines stack up. It's very similar. So again, I'll draw my x and y axis. And this one goes through 4, 8. So we'll come over here, we'll say 1, 2, 3, 4, and somewhere up here at 8. We'll call that 4, 8. And then I have a vertical line, so straight up and down. So this is really steep. It's actually so steep that we can't calculate. It's an undefined slope. And the only axis it touches is going to be the x-axis, and it will touch it right here at 4. It's neither, every point on here has a value of 4 for x. It's nothing to the left or to the right of it. So this actually just has a simple equation of x equals 4. So horizontal lines that pass through the y-axis have equations of y equals wherever they pass through. Vertical lines that pass through the x-axis have equations of x equals wherever they cross through. And if we find equations given 2 points, it just requires us to use 2 formulas. We have the slope formula, and then we can use it, our slope-intercept to finish off. So I'm going to first have to find the m, and then I use the x and the y from a point to find b. So it's an extra step from what we were doing in a couple problems right at the beginning. So the first thing I'm going to do is I can label these x1, y1, x2, y2. Doesn't matter which pair I labeled the 2's versus the 1's as long as I don't put x1, y2. So then we put our 8 minus 5 over 2 less 4. 8 minus 5 is 3. 2 minus 4 is negative 2. So I have a slope of negative 2/3. So there's my m. I don't know the b. Just going to put a little question mark. And then I have these 2 coordinates. And I can pick either one of them. It doesn't really matter. I'm going to pick the second set. And then we'll go ahead and sub it all into our slope-intercept formula. So I have y equals the slope times the x value plus b, and b is my unknown. And then we begin to solve. So I have negative 2/3 times 2 is negative 4/3. And then we will add that to both sides. So that's going to leave me with 4/3 is 1 1/3, so that's going to be 9 1/3. and there's my b value. So I'll rewrite the equation. Y equals negative 2/3 x plus 9 1/3. That's our equation of a line through those 2 points. And this one, actually, I apologize, it asks us to write it in standard form. And we can certainly do that. Remember, standard form from the prior section is ax plus by equals c. And so in order to do that, let me clear out some of this here. A couple rules to standard form. No negative for the leading coefficient of x here, and no fractions. So I'm going to rearrange this, write it over here, negative 2/3 x plus 9 1/3. I'm going to go ahead and convert this to an improper fraction. 9/3 is 27/3 plus 1/3, so that's 28/3. You'll see why I did that in just a second. And I need to bring the x's over, so I'm going to add 2/3 x's. That's going to leave me with 2/3 x plus y equals 28/3. So I'm partway there. I've got it as ax plus by equals c. However, I've still got the fraction. So if I multiply everything by a 3, I can go ahead and remove that. So I'll multiply this side by a 3, multiply that side by a 3. Those will cancel, and I'll just get 2x plus 3y equals 28. And we'll look at another here. We'll write the equation of a line with x-intercept and y-intercept of 6, 0, and 0, 4, and then they want it in slope-intercept form. So if I were going to represent this on a graph real quick, just to give me a picture, draw my y-axis, x-axis, and my line goes through somewhere over here, 6, 0, and 0, 4, so probably something like that. 0, 4, 6, 0. A couple different ways I could do this. I can do it as the one you saw previously, where I calculate the slope and then calculate b, the y-intercept, which I already actually have in this case. So that makes it pretty easy. I could also think about this as just counting on a grid down and over and find the slope that way. But let's go ahead and calculate it using the slope formula. So I'm going to y sub 2 minus y sub 1, x sub 2, x sub 1. I'll just label these to keep everything straight. Then we just sub it in. I say I get 4 minus 0. 0 minus 6 reduces to negative 2/3. So there's my slope. So y equals negative 2/3 x. And then I need b, the y-intercept, but they already tell me that here. So plus 4. And the next example here, write the equation line represented by the table or graphs. So this is just a different way to give you the information. So I see that if I draw this, when I'm at 0 on x, I'm at negative 3 on y. So that's down here. So that tells me that's actually the intercept. So for slope, b, I just found b. The intercept then is negative 3. So an x and a y. You can also look at this, and because I have a table, it's pretty easy to find the slope, so I don't really have to pick another point, sub it into the equation to find the slope. Because if you look, every change that you go up or down, so see when I'm at 0 and I go up 1, up 1, up 1, what's happening to the y value? How's it changing? It's actually moving down by another half. So I go up 1. So if you think of it like this, I'm going from 0 to 1, 0 to 1 on x, and I'm up at, or down at rather, negative 3.5. I go over one more, I'm down at -4. Over one more, down at -4.5. So I see that I have a negative slope, and it's changing for every unit on x, it's changing by half a unit on y down. So that's a -1/2. And there's my equation. If I wanted to check that, I could certainly just put this in the calculator. Y equals negative, we'll just say 0.5 on this one, -3. And I should get a table that matches. And we do, so we know we've done that correctly. I could also put these in stat plot, and I could find the regression form as well. Another one here. Personally, I think it's easiest to find the equation of a line when you have the graph of it, because you can just count the slope very easily. We always run to the right, so that tells me this is a negative slope. So if I'm going to write this in slope-intercept, I start at this point, and I go down 1, 2, 3, 4. So down 4, and then I run 1, 2, 3, 4, 5, 6. So that's -4/6, which is -2/3. There's my slope. And it looks like it crosses right at -4. So when you have a graph, it's very easy. You just look at where does it cross y, how much up or down, and over to get to the next point on my line. So again, on this one, y equals mx plus b. Start on my line, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. So that's a rise of 9, run of 3. So this has a slope of 3. And it looks like my intercept is right there at -4. And we'll look at the last example here. So this word problem, we're going to go ahead and set it up. I'm going to treat these like coordinates. I have an x and a y. In 2000, the small town had 250 employees. In 2005, it had 325. Assume the growth is linear and write an equation of a line to represent the number of employees, y, versus the number of years since 2000, that's x. Use this to predict the number of employees in 2010. So if I treat these just like coordinates, I have an x value of 2000, y value of 250 people. Then I have a second ordered pair of 2005 and 325. I see as the years increasing that the people are increasing, so that appears to be a positive slope. So if I'm going to go ahead and write an equation for this, I can label them. We'll call this x1, y1, x sub 2, y sub 2, and we'll plug it in the slope formula. 325 minus 250 over 2005 minus 2000 equals, looks like 50 would be 300, 75 there, over 5 years here, 75 over 5. It's 15. So there's my slope. And then I can pick one of these to find the y-intercept. So we'll go ahead and just stay with the top ones here, 2,250. So we'll say m equals 15. B is my unknown. X, I'm going to use 2,000. Y, I'm going to use 250. And we'll sub it into the slope formula. So y equals m times x plus b. And now we'll just rearrange. Pull up the calculator. I have 15 times 2,000 equals 30,000. Plus b. We subtract 30,000 from both sides. So there's my b. Now we can write the equation of the line. Y equals m times x minus 29,750. And if we look at that in the calculator, Now it's not going to show up on the standard viewing window because it's only 10 to 10. So I can say zoom, and I can try to make it fit. And there we go. So I see the intercept way down here. Easiest way to find these is going to be to look at your table. But if you go directly to your table and you haven't adjusted your graph, you're going to see probably somewhere the center's around 0, unless somebody's messed with it. So if I go into my table set, I can start that at 2000, year I had. And I see the first value 250. I go to 2005, I have 325. I go to 2010 and I'm at 400. I could also just substitute it in here and calculate it. So 400 employees by the year 2010. So have those filled out and be prepared for class, and we'll get a little bit more practice.